Hi everyone, let me introduce you with Chi Hao. He's going to talk about speech-to-text solutions that can automate the case note taking. Over to you, Chi Hao.
Okay, hi. Thanks, Anna. Thanks, Anna. Hi, everyone. Today this is our presentation. I represent my group from my NTU, and just going to share with you what we have done so far, and hopefully we can work together in future. Okay, so basically I'm from the team in NTU. This is my whole team. So we are just a small, maybe 10 to 15 man team. So it's fine lah. Huh? I won't introduce further. So let's proceed to the main thing. Today you can see that actually our site is made of two professors, one from NTU and one is from NUS, right? Both of them came together and we created a speech lab. And most importantly, it's under AI Singapore, and we are doing something called 100 experiments, and we're looking for partners to develop an engine for the commercial deployment lah. Right. So currently we only deploy in MSF call center as well as the SCDF call center. Okay, so moving on, what is our basically core competence, I can think of it this way. So you can see is that we are here to provide a speech recognition system for Singaporean to recognize the Singapore accent. Let's say today, 如果我今天讲华文，然后 I speak English, you can see that this particular system can capture both lah. So this is a very straightforward thing, but we have been doing this for maybe about 10 to 15 years. Yeah. So just to go through a bit, this is our speech recognition engine. It's comprised of three modules. First module is the dictionary, which is also known as the lexicon. Okay. Second part is the acoustic model, with something that you can think of it as how to pronounce. And then the last one, the language model, you can think of it as what is being said. Okay. So these three parts itself requires fine tuning for every use case. And let's say one of the things is that we can change is the dictionary between, let's say, a math lecture versus let's say a medical scenario lah, right? So you can see that ASR itself is a very dedicated problem. Every single speech engine is it's tailor made for the conditions, and this is where our strength lies, is that we provide a customized solution, right? As opposed to most product where they have a one size fit all. Simply because, like I mentioned before, this speech engine, right, is a very customized thing lah, and that's what we do. We customize to local accent as well. And on top of that, because we are a speech team in the university, we actually handle very sensitive data. And unlike other cloud-based solution, right, we don't store your data, right? So this is our differences between us and the commercial, let's say, off-the-shelf products lah. Okay. So moving on, just to share with you what we have done so far in the past few years. For the past decade or so, we have been concentrating on a classical automatic speech recognition system, right? So you can see the top left corner, the picture of two people lah. So the two person, right, they are wearing something called a closed talk microphone, right? When the microphone is close to the mouth, right? This is a very classical scenario. Okay, and what happens is that you get very clean speech signal, meaning to say that you can get very high accuracy. So if you have been noticing, there's this the words have been appearing below, right? This is actually done live. As I'm talking, the words are appearing, and you can see that the accuracy itself, I would say, is about 70 to 80%. It's quite high. But the cons, right, the downside to such thing is that as I'm wearing this microphone, it's very cumbersome, it's very heavy, it's very hot, and it's not what most people want, right? So the modern automatic speech recognition solution is that when you can see at the bottom right hand corner, there's two microphone. This microphone is very far away from the mouth itself. So meaning to say, the downside is that this is something known as a far field signal. It's noisy and it's weak, meaning to say that the accuracy of such system is very low. the current accuracy, right? But the good side is that most people prefer this solution, even though the accuracy is lower. This is because, right, it's non-intrusive and it's very suitable for, let's say, meetings or one-to-one interview. Yeah. Okay, so some of the modern use cases, right? The speech recognition use cases. So you can see is that increasing order of difficulty, right? So first of all, CT mics means a closed talk mics, right? Closed talk microphones. What this means is that the microphone is very, very close to your mouth. And then, of course, as the microphone leaves the mouth and then you go to one-to-one interview, the challenges increases, right? You get a little bit of noise, a little bit of reverberation, and the signal becomes a far-field signal, right? So we can see that the meeting room itself is a very challenging scenario that we would want to tackle, but in the near future, right? Once we tackle the one-to-one interview, right? But why we still want to tackle this problem, even though it's quite hard to do, that's because we know we understand the downstream application of all the auto transcription. We can use it for logging, we can use it for minuting, we can even use it for, let's say, summarization. So you can see that the application is a lot, right? So that's why we want to continue further in this type of research, as well as partner with people to actually develop this system together. Okay. So just also to share, we also did a trial with the MSF, the Social Service Office, the SSO, if I'm not wrong. Yeah, and mostly they do a one-to-one interview, and they have they interview in English and Mandarin, and sometimes the dialect itself lah. Okay. One of the pain points is that for this particular type of interview, there's many interviews, and sometimes they need to transcribe the case reports, and it's a it's a menial task lah, right? And this was the setup that we have. You can see that the microphone is placed on the table, and then the interviewer and interviewee will talk to each other lah. And what we have learned is that this is the officers were impressed by the Singlish capabilities lah. But of course, because it's a far-field microphone, it's a far-field signal, what happened is the accuracy is very, very, very low, right? Yeah, it's about 50%. And on top of that, if you were to, let's say, wear a microphone, the interviewer is also uncomfortable. You know, you will maybe cause some trouble lah, with the interview and the recording itself. So, and finally, we realized that the interface is also not user friendly, simply because the user itself, most of the interview, the person conducting the interview, they may not be tech savvy, right? So that's one of the things that we learned, and because of this, we realized that we want to find more parties to work together and develop such a one-to-one interview room scenario, right? And at the same time, to provide recordings and to build a corpus with us. At the same time, also to finally develop a user interface together with AI Singapore lah. And then this particular product will belong to MSF, and in particular maybe NCSS lah. Yeah. Okay. So I've come to the end of my presentation, and so thank you in particular NCSS for inviting me for this presentation. Thank you very much. And if you have any question, you can email me myself, which I think Lisa will be my point of contact lah, from your side.
Okay, thank you, Zhihao. Also, for those of you who are interested to try out this technology or these solutions, you can contact NCSS, whether it's Lisa Ng or myself, Anna Jong. Okay, thank you, Zhihao. Bye-bye.